morning children. My name is Sudeshna Mukhopadhyay. I am your new maths teacher. I'll be taking your classes according to the timetable set by the school. Okay, follow the each and every video sent by me, and at the end of the video I'll be giving you one assignment and you have to return back the assignment within 1 day. Okay, solve it, and whatever doubts you have you can clarify it with me, and in this way we have to continue our studies because there is no other option left. I know it's very boring sitting at home all the time, and you may be feeling when you will be coming to school, but you know we are facing we are going through a great pandemic situation. So but we have to study, we have to score good marks in our exam, right? So all the best. So let's begin with the first chapter of class 10 maths, that is real numbers. So let's begin. Suppose I give you a number as 13 and tell you to divide by 2. How will I divide 13 by 2? You will write 2 13, right? We all know 6 2s are 12 and 1 is the remainder, right? So in this division, what is 2 known as? 2 is known as divisor. What is 13 known as? Dividend. What is 6 known as? Quotient. And at last 1 is known as remainder. Right? In the division, whatever we divide, that is known as dividend. The number which divides the dividend is known as divisor. The answer that we get, means the factor which multiplies with the divisor, is known as quotient, and the answer remain after subtraction, whatever we get, that is known as remainder. Now, can you formulate this whole process into a single line? Yes, we can do that. Why? How? Let's see. If I write 13, okay, and I want to express this whole division in one line, what will I write? 2 into 6 plus 1, right? 6 2s are 12, 12 plus 1 is 13. So I have expressed the whole division in one line. So always we can do that. That is, we can always represent dividend is equal to divisor into quotient plus remainder, right? For all positive integers, we can say that dividend is equal to divisor into quotient plus remainder. Okay. Now, if I consider this dividend as A, okay, and this divisor as B, quotient as Q, and remainder as R, then I get one formula, that is A is equal to BQ plus R, okay, where R is less than equal to 0, R is greater than equal to 0 and less than B. Okay, why r is less than b but greater than equal to 0. You see, what is b? B is the divisor. Okay, whatever is the divisor, okay, whatever is the divisor, you will always find that the remainder is smaller than that. It can't be greater than the divisor. So this whole thing where a and b are positive integers, if we can formulate this whole thing, we can say it as Euclid's division algorithm. Right? So what is Euclid's division algorithm? If I state it, Euclid's division algorithm states that given positive integers, say a and b, there exists unique means it's different, means it's unique means it's not the same. Okay, unique integers q and r satisfying one equation a is equal to bq plus r, where 0 r is less than equal to 0 and r is greater than equal to 0 and less than equal to b. Okay, so any positive integer, suppose we have two positive integers a and b, then there will exist two integers q and r which will satisfy the equation, which is a is equal to bq plus r, while r is the remainder and it will be always greater than equal to 0 but less than b. B means here the divisor. Okay, now in your junior classes you have come across two terms. One is HCF and another is LCM. Now what is HCF? HCF means highest common factor, right? HCF is highest common factor. And what is LCM? Least common multiple. HCF is highest common factor and LCM is least common multiple. Now we will use Euclid's division algorithm to find HCF of two numbers. Now how we will do that? Let's see. Now before, when you were given to do HCF, suppose I have given you two numbers like 24 and 36. Okay, now I told you to find HCF of these two numbers. Okay, now how will I do that? Previously what you had done, you had to take 24, divide by 36. 24 ones are 24, 12 comes as remainder. You see, remainder is less than 24, right? Okay, next again 24 we used to divide, again 24, 12 twos are 24, so 24 and the remainder is 0. Okay, this was our initial process of doing HCF. So what was our HCF then? 12. Now if I tell you to use Euclid's division lemma, or lemma means, don't get confused, lemma means just a statement that is proved, okay, that is used to prove. Now the statement is known as lemma, okay. So if I tell you to use Euclid's division algorithm to do this, solve this, okay, how will you do that? Okay, let's start. Now let us express, there are two parts of the division, right? This is the first part of the division and this is the second part of the division, right? So let's state the find out how to do using Euclid's division method to find out HCF of two numbers, that is 24 and 36. For the first part of division, what will you write? 36 is equal to, what you will write? 24 into 1, and what is the remainder? 12. So 12, right? See, 36, 24 into 1 is what? 24, and 24 plus 12 comes 32. So I have expressed this first part of division, right? Now the second part. For the second part of the division, what will I write? Second part, you see, 24 is the dividend. So 24 is equal to 12 into 2 plus 0, right? It is the second part of the division, means our process of HCF in the second part. So see, when we do an HCF by using Euclid's division method, what is our thing? We take the first bigger number, which is the bigger number among the two numbers given. We first take that number and we use Euclid's division algorithm to find that. We will always try to find how many times this number can come. Okay, we'll try to find, at least we'll try to find, okay, and whatever is the remainder, will be just adding to it, okay. In the next part, what we will be doing is, we'll take the quotient, we'll be taking the, the divisor again as in the next step, okay, and we will be finding how many times it goes with the remainder, utilizing the remainder, how many times it goes, and we will add the remainder to it. Understood? So simply this thing, if I formulate in a simple step, what will I say that? Let's see. So if we state Euclid's division algorithm to obtain HCF of two positive integers, what we will write? For two positive integers, see, I am writing positive in this way, but don't write this in your exam, okay? For two positive integers, let it be C and D, okay? For two positive integers C and D, such as, one have to be greater, so let C is coming first, so I am making it greater, okay. C is greater than D, okay, such as C is greater than D. Apply Euclid's division algorithm C is equal to dq plus r, where r is greater than equal to 0 but less than d. Okay. Understood? Now how long will you continue this process? Next step, if r comes as 0, okay, if r is equal to 0, then d is the HCF. Okay, if r comes as 0, then d is the HCF. But what if r is not equal to 0? If r is not equal to 0, then apply the division algorithm to D and R. Okay, you will forget about C. Okay, you will consider only D and R. Okay, that time D will come in place of C, and with R R will come in place of D. Okay, and you have to find out, you have to go on till how long will you go on? Continue until R becomes 0. Okay, continue the process till R becomes 0. So I am rewinding it once again. So how can we interpret HCF in form of Euclid's division lemma? That is, for any two positive integers, the number should be positive of course, and such as one number is greater than other. It can't be equal. Okay, you can't take equal numbers and you can't do that. So one number have to be greater than the other. So let the greater number be C and the smaller number be D. Now if you formulate that, if you use the Euclid's division algorithm, C is equal to dq plus r, where r will be always be less than greater than equal to 0 and less than d. Okay, and if r comes as 0, that means if the division cannot be proceeded further, then d, whatever is there in place of d, that will be the HCF of the number. If it is not so, if the r is not equal to 0, then apply the division algorithm to d and r. You will forget about c, and in place of c, means same way as you have done C is equal to dq plus r, in same way you will just put the in place of d you will be writing in place of C you will be writing d, and in place of d you will be writing whatever value you have got for r. With that value you will be doing the division algorithm again, and you have to continue the process until the whole the r becomes 0. Now suppose you are given one question that you have to show that every positive even number is in form of 2q and every positive odd number is in form of 2q plus 1. Okay, and q be some integer. Okay, so what is our question? What is our question? That every positive even integer will be 2q and odd ones will be 2q plus 1. Every positive even integers will be 2q and odd ones will be 2q plus 1. Okay, and whereas where q is one integer, some integer. Okay, so how will you do this using Euclid's division method? So what was Euclid's division that algorithm? It was A is equal to BQ plus R, where R is always less than equal to, R is always greater than equal to 0 and less than B, right? Now, as this is even integers, we need to find even integers, right? So, if A and B are positive numbers and we have to find for even integers, that means B will be what? B will be 2. Even numbers, how do we find out? We find out by dividing by 2. If it is a perfect division, that is if there is no remainder, that means it is a perfect division, and that means it's an even number. And if there is a remainder as 1, then it will be odd number. Okay, so we can say that A is equal to 2Q plus R, right? Now what will be the value of R? Now value of R, since B is equal to 2, so it will be between 0 and 2. So between 0 and 2, R can be either 0 or R can be 1, right? So we can write it again as A is equal to 2Q plus 0, which means A is equal to 2Q, and another we can write as A is equal to 2Q plus 1, right? So if in the remainder part it is 0, that means what? It is a perfect division. So it means this is an even integer. And if there is a remainder, that means it's not a perfect division. That means it is an odd integer, right? So whenever you get this type of question, always remember, first thing you have to decide is what will be my divisor. Okay, if it is by 3, then it will be 3. If it is by 4, then 4 will be your divisor, and you have to find out what will be the values of R, how the values of R will what will be the means within what the values of R will remain. Okay, that you have to find out. So let's see more questions like this. Now suppose for the next question, suppose you are given one question like using Euclid's lemma. Okay, I'm writing Euclid's lemma, and we will use to show any positive number is either in form of 3m or 3m plus 1. Okay, let this be question that using Euclid's lemma we have to show that any positive number is either in form of any positive square of any positive number, square of any positive number is either in form of 3m or 3m plus 1. Now see, how will we solve this type of questions? Now see, 3m. Okay, now from this only, what we know by Euclid's lemma, we know A is equal to BQ plus R, where R is greater than equal to 0 and less than B, right? Now here we have 3. Okay, so that means what? The value of B is 3. Okay, so what will be the value of R? R will be between 0 and 3. Okay, what can be the value of R? R can be 0, 1 and 2, right? It cannot exceed 3, right? It have to be between 0, 1 and 2. Now, what is the trick in the question? What is the twist in the question? It is, we have to find the square. Okay, so square. So A is equal to, suppose we have 3Q plus R. Okay, now considering R is equal to 0, considering the first case, if R is equal to 0, then what it will come? A is equal to 3Q plus R, or we can say if R is 0, that means it is 3Q. A is equal to 3Q. Now our question was square of any positive number, so squaring both sides. Squaring both sides, what we will get? A square is equal to 3Q whole square, which means 9 square, right? Or we can say 3, if we take common, 3Q square, right? Now if we consider this as any other positive integer, as this is squared, you can see, if we take this as any positive integer, say k, okay, k1, so we can say 3k1, right? Now considering the next one, if the value of R is 1, what it will become? It will be A is equal to 3Q plus 1, right? A is equal to 3Q plus 1. Similarly, as it is square, we have been asked for square, so squaring both sides, what do we get? A square is equal to 3Q plus 1 whole square, right? Now 3Q means what? This one if we break, what we will get? We will get 3Q square plus 2 into 3Q into 1 plus 1 square, which means 9Q square plus 6Q plus 1, right? Now from here you see we can take 3 as common. Okay, we can take 3 as common. If we take 3 as common, what remains? 3Q square plus 2Q, okay, plus 1. Now this is, let us consider this as another positive integer. So we can say that let this be k2. So we can say that 3k2 plus 1. Understood? So I am erasing off this side. Okay, please note it down. I am erasing off this side. Now our next value of r is what? 2. Okay, so again same process, 3q plus 2. So squaring both sides, we have a square 9q square. I'm not showing it again. Okay, similarly in place of 1 you will just write 2. Okay, and 12q plus 4. Okay, or we can break now we can break this one as 9q square, because it will be easy for us, no? So 12q plus 3 plus 1, because we need to take common 3. Okay, so we can say 3 if we take common, then what remains? 3q square plus 12q plus 1 plus 1. Okay, now let us consider this as k3. Okay, now what we can see from here, 3k3 plus 1, right? Please note it down. Now you may say that why am I taking k1, k2, k3? Here the question was m, okay, but I didn't take m, right? Why have I taken k1, k2, k3? Now previously I have told m is any integer. Okay, previously I have already told that m is any integer. Okay, so here I have considered k1, k2 and k3 also as some of the integers. Okay, so we can say that, just a minute, so we can see that instead of writing m, k1, k2, k3 are all some integers. Hence we can say square of positive numbers are either in form of 3m or 3m plus 1, because why? When r was equal to 0, we got what? We got 3k1, right? When r was 0, we got 3k1. When r was 1, we got 3k2 plus 1. And when r was 2, we got 3k3 plus 1. Okay, understood? So as m is an integer, so let k be also any integer, so some integer, so we can say the square of positive number is either in form of 3m or 3m plus 1. So I am giving you 5 questions, okay, and you need to solve them and return back to me, okay, after within 1 day, okay. So your first question, assignment 1, okay, this is your assignment 1. First question is divide 72 by 13, okay, divide 72 by 13 using Euclid's division method. Second, find HCF of 124 and 36 using Euclid's division. Third one, show any positive odd integer is in form of 2q plus 1, okay. Fourth one, okay, where q is some integer, and the fourth one is show any positive odd integer is in form of 6q plus 1, 6q plus 3, or 6q plus 5, where q is some integer. And the fifth one, using Euclid's lemma, show cube of any positive integer is in form of 9m plus 1 or 9m plus 8. Okay, these are the 5 questions that I have given you. Divide 72 by 13 using Euclid's division method. Second question, find HCF of 124 and 36 using Euclid's division. Third one, show that any positive odd integer is in form of 2q plus 1, where q is some integer. Fourth one, show any positive integer is in form of 6q plus 1, 6q plus 3 or 6q plus 5, where q is some integer. And the fifth one is, using Euclid's lemma, show that cube of any positive integer is in form of 9m, 9m plus 1 or 9m plus 8. Okay, note it down. So that was for the first video. That was your first maths video. At the end of the video, I have shared one assignment. I have given you the assignment. Please do go through all the problems, okay, that I have solved. I hope that you're sitting with pen and paper when you're attending your maths classes, and go through each and every problem, solve them, and try to do it by yourself. Okay, and I think that won't be much hard if you start from the beginning. Okay, so we'll be seeing in the next video.